Foundations of Amateur Radio. In our hobby, we regularly invoke line of sight when we discuss the VHF and higher bands. It's a simple concept to help describe when two transceivers can hear each other. The process evokes an image of a beam of light travelling unobstructed between the antennas at either end. Some might picture a laser, others a flashlight. Both are useful to become familiar with some of the concepts. If there's a pole between the two, a laser beam, unless it's particularly powerful, won't go through to the other side. A flashlight beam, on the other hand, might fit around the pole and still be visible at the destination. That illustrates that objects can get in the way of a signal, reducing strength and sometimes blocking it entirely. But it's not the only effect at play. Imagine a building with a mirror glued to its side. If you shine a laser at an angle at the mirror, you can reflect the light off the mirror and essentially still land on target. This is useful if you want to avoid an obstacle directly between you and your destination. The reflected light travels a different and slightly longer distance than direct light would, but if there's no obstacles, both will arrive at the destination. This is an example of a multipath, where the same signal arrives at its destination using multiple different paths. If you've ever used HF radio, making a contact on the other side of the planet, it should come as no surprise that radio waves travel in more than just straight lines. Depending on frequency, radio waves can be affected by phenomena like ionospheric reflection and refraction, atmospheric ducting, and even bounce off water, the ground, mountains, hills, and objects like buildings, aircraft, and even water droplets along their path. Each of these cause a radio signal to take multiple paths to arrive at the destination. It gets better. A radio signal that travels along a different path takes a measurable difference in time to get to its destination when compared with another path for the same signal. From a radio signal perspective, this difference in time is also known as a phase shift. Now consider a single radio signal that travels along two paths, just like our laser beam and mirror. If you imagine a radio signal as a sine wave, you can draw the two signals on the same chart. They will be in lockstep with each other since they're the same radio signal, but they won't be on the same place on the chart. In relation to each other, they'll be shifted along the time axis, since one took longer than the other to get to the destination. At the destination, the receiver hears a combination of both those signals. They're added together. That means that what's sent and what's received are not the same thing, and why it's a great idea to use phonetics in radio communications. In some cases, the two signals help and strengthen each other. They're said to interfere constructively. And sometimes the signals hinder and cancel each other out, or interfere destructively. Said in another way, a radio signal can arrive at a receiver along multiple paths at the same time. What's heard at the receiver is essentially a cacophony caused by each slightly different path. Since the signals are essentially all the same, some of these signals reinforce each other, where some cancel each other out. This effect isn't absolute, since the different path lengths aren't all exact multiples of the wavelength of the signal. They're all over the place, but there will be groups of paths that help and groups that hinder. This phenomenon was first described by Augustin-Jean Fresnel on the 14th of July 1816 in relation to light, and we now call these groups Fresnel zones. Fresnel zones are numbered 1, 2, 3 and up. The first or primary Fresnel zone is the first group of radio signals that helps strengthen the signal. The second zone is the first group of signals that hinders. The third zone is the second group of radio signals that helps, and so on. Odd helps, even hinders. I should point out that a Fresnel zone is three-dimensional. The primary Fresnel zone essentially has the shape of a Zeppelin stretched between the source and the target. The secondary zone is wrapped around the outside of the primary zone like a second skin, but it's thicker in the middle. In practical terms, what this means in point-to-point radio communications is that your antenna needs to be located in a place where most of the signal arrives. The rule of thumb is that the primary Fresnel zone needs to be at least 60% clear, but ideally 80%. If you're in a situation where a receiver is moving, say in a car, you can imagine that your antenna is moving in and out of direct line of sight to a transmitter. But it's also moving between the various Fresnel zones. If you were to move your antenna from the first Fresnel zone to the second, and then the third, the signal would be strong, then weak, then strong again. If your receiver is an FM receiver and it's moving from the first zone to the second, it could fall below a threshold and the signal would effectively vanish. Continue to move from the second into the third zone and the signal would sound like it suddenly reappeared as it climbed above the threshold. Do it fast enough and the signal sounds like it's stuttering. That stuttering has a name. In amateur radio we call it picket fencing or flutter, and it's commonly heard in mobile situations on FM transmissions on the VHF and higher bands. But it can be caused by other changes in propagation distance, for example an antenna moving in the wind. The higher the frequency, the less movement is needed to experience this. To add to the fun of radio, the same threshold effects, actually called the FM capture effect, can be caused by other phenomena, like two stations of similar strength on the same frequency, or interference from the electronics in your vehicle. And finally, I should point out that the higher the frequency, the smaller the Fresnel zones, and the more susceptible to an object in the path a signal is. But you already knew that. A pole will block a laser beam, but not a 2-meter conversation on the local repeater. So, line of sight isn't just a straight line, it's a whole lot more fun. I'm Onno, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.